So here we're given this quadratic equation, and we're actually not given the coefficient of x squared term, but we're told that the two roots are minus 2/3 and 7/5. So let's look at the corresponding equation of the parabola. And actually, the argument doesn't depend on whether a is positive or negative, but let's say a is positive. And the two roots are minus 2/3 and 7/5. So let's say the parabola is something like that. This is minus 2/3, 7/5. Now the question is asking for the solution to this quadratic equation, and if you notice, the difference is that instead of x, it's x plus 1. So this is the equation of, say, y equal to f of x parabola. The question is, what happens to the parabola f of x plus 1? So replacing x with x plus 1. This corresponds to a horizontal shift. And this is a horizontal shift to the left, 1 unit. So that means that the parabola that corresponds to this quadratic equation would be 1 unit to the left. So something like that. This should be the same here. That means that the roots will also shift, because there's no shift up or down. This is just a horizontal shift. So this root here, the 7/5, would go 1 to the left, so that would become 2/5. That's one of the roots. And the other one would be minus 2/3 minus 1, which is minus 5/3. So the two roots are minus 5/3 and 2/5, which is answer choice B. So this is the most efficient way to do this problem. They're not really expecting you to solve it in a traditional sense, because it is kind of a hard one. If you had to do it the long way, which is not recommended, but the way you would do this is you would start by finding what a is. So you replace x with minus 2/3. So I'll do it this way as well. Actually, I haven't done it, but it could become complicated. So this is 4/9. That's 22/3 minus 14. So this becomes a 4/9. I'm going to move these terms over. 14 minus 22/3. So this becomes 42 minus 22/3, which is 20/3, which means a is 9/4, 23rd. Actually, nice number so far. A is 15. So our quadratic here is the ones we have to find. The solution is this. Now, one approach would be to square this and then factor it, or the other would be to call x plus 1 z. So that's this. And actually we can use our earlier results. Actually we'll get the same answer, because this here, we know that the roots, because are minus 2/3 and 7/5, which means that 3x minus 2, that would be the corresponding, actually 3x plus 2 and 5x minus 7. That's that corresponding. You can expand this. You'll notice that 15x squared plus 10x minus 14, you will see that comes back to the same as this original one. And the way I've constructed is that you do x minus 2/3, x minus 7/5 equal to 0, and then you'll get 3x plus 2/3, 5x minus 7/5. These terms, if you multiply both sides by 15, disappear, because if you have a 0 here. So you end up with this. So that means we can also factor this directly, which means this would be 3z plus 2, 5z minus 7 is 0. So we don't have to even solve this, because those are the roots. And now that we equate this to x plus 1 in both cases to get the roots to this equation. And you'll notice that again I am subtracting. So I end up with the same result as before. So in case you don't recognize that, the long way would be to do this. A little bit longer would be if you went and did the expansion and then cleaned up that quadratic, then solved it. It would be a lot of work, and that's exactly, I guess, what the writers are doing, is to have you waste your time. But the most efficient approach is to recognize that this is really just a horizontal shift. So to recap, the answer is B.